Good afternoon to all. Thank you very much, Heather, for setting the scene. And what I'd like to talk to everyone this afternoon is about two studies that we did as collaborative projects between Devonish Nutrition and the Royal College of Surgeons in Ireland concerning the benefits of eating omega-3 polyunsaturated fatty acid enriched chicken meat and eggs on plasma levels of omega-3 polyunsaturated fatty acids and the omega-3 index. Now, Heather has very carefully covered the evidence that greater consumption of oily fish or elevated plasma levels of omega-3 PUVAs are associated with protection from heart attacks, strokes, cancer, diabetes mellitus, and indeed improved brain health, vision, muscle and joint health. But I'd also like to discuss with you, how do the omega-3 polyunsaturated fatty acids work? You can see here that the omega-3 fatty acids are concentrated in the lipid bilayer of cell membranes. And while they're there, they have two main functions. They stabilize those cell membranes and they're anti-inflammatory. How they stabilize the cell membranes is that they actually work with the ion channels, which are proteins embedded in the cell membrane, and with protein receptors, and they improve or optimize the function of those ion channels and those receptors, making the cell membranes more stable and improving cell-to-cell communication. The second major function of the omega-3 fatty acids in the cell membranes are that they're anti-inflammatory. The omega-3 fatty acids form the starting substrates for many lipid mediators, such as the eicosanoids and the leukotrienes. And prostaglandins, leukotrienes, and thromboxane that are formed from omega-3 fatty acids as opposed to omega-6 fatty acids are much less inflammatory and less thrombotic. With the knowledge concerning the epidemiology of the benefits of omega-3 fatty acids, and with our knowledge of the molecular biology of the omega-3 fatty acids, and lastly, with the recently produced omega-3 enriched chicken meat and eggs from Devonish Nutrition, we were very much encouraged to do a pilot study in humans, which we did in 2013. And we looked at, could we increase the omega-3 levels in these humans if they ate omega-3 enriched chicken meat, and were there benefits? We did this study in 30 subjects over a period of 5 weeks. The 30 volunteers, relatively young, healthy, adult volunteers, all ate omega-3 enriched chicken meat at least 3 times weekly. And we looked at the plasma levels of omega-3 at baseline, at week 1, at week 3, and at the end of week 5. And you can see there was an incremental increase from a baseline of the sum of all 3 omega-3 fatty acids of 82.5 to 88.8 to 89, and then up to 92.9 at week 5. About a 14% increase in omega-3 levels, which was highly statistically significant. We not only looked at the levels, we also looked for an impact on blood pressure and on platelet stickiness or platelet reactivity or turnover. With eating the omega-3 enriched chicken meat for 5 weeks, we got a 3 millimeter drop in systolic blood pressure from 116 to 113 millimeters of mercury over the 5 weeks. A drop of 3 millimeters of mercury of systolic blood pressure is associated with about a 25% reduction in heart attacks and strokes, so certainly beneficial. Likewise with platelet turnover, platelets adhere to each other and cause clots which block blood vessels and contribute to heart attacks and strokes. One of the best measures of how reactive or how sticky platelets are is the urinary thromboxane to creatinine ratio. With eating omega-3 enriched chicken meat, we got about a 30% reduction in urinary thromboxane to creatinine ratio. Just to put that in perspective, aspirin, low-dose aspirin, which is used to protect against heart attacks and strokes, results in a 50% reduction in this same measure. So again, very encouraging effects on biomarkers of disease. The pilot study very much facilitated the design and conduct of a double-blind randomized control trial, which we completed in 2017. The aim of this study was to study the impact of eating chicken meat and eggs naturally enriched with algae-sourced omega-3 PUVAs. The primary endpoints, which are the results that I'm going to share with you today, were plasma levels of omega-3 PUVAs, DHA and EPA, and also the omega-3 index, which is the best measure of tissue levels of omega-3s. We also measured a range of cardiovascular and neuropsychological measures. These are still being analysed, and I'm not in a position to share those with you today. The study design, it was a randomised, double-blind controlled study with a 2-by-2 factorial design conducted over 6 months, so much longer than the 1-month study of the pilot study, and it was much bigger. Rather than 30 subjects, we had 161 healthy participants randomized within this study. Now, they were randomized in 2 ways. They were asked to eat at least 3 portions per week of omega-3 PUVA enriched chicken meat or control meat. And they were also randomized to eat at least 3 omega-3 PUVA enriched eggs per week or at least 3 control eggs. So 40 subjects were randomized to eat control chicken meat and control eggs, 40 to eat control chicken meat and omega-3 PUVA enriched eggs, 40 to eat the omega-3 PUVA enriched chicken meat and control eggs, and then the last 40 ate enriched chicken meat and enriched eggs for the 6 months. Most assessments were actually measured at baseline, after 3 months, and also after 6 months. These are the main results. In the upper 2 panels, the results for plasma DHA, and in the lower 2 panels, the results for plasma EPA. The 6-month values are on the right-hand panels, and the 3-month values are in the left-hand panels. And I'm just going to take you through the results for plasma DHA at 6 months. Those who were randomized to eat control chicken and control eggs, there was no change in plasma DHA, which is exactly what we would have expected. There was an increase with eating omega-3 enriched eggs. There was a further increase, a greater increase, with eating omega-3 chicken meat, and the greatest increase was seen in those who ate omega-3 enriched eggs and omega-3 enriched chicken meat. All of the subjects that ate omega-3 enriched products, there was a statistically significant difference compared with the control group. Now, the omega-3 eggs were only enriched for DHA, so in fact there wasn't an increase in EPA with eating omega-3 eggs. There was a statistically significant increase in EPA with eating chicken meat. From the values that we got in plasma levels of omega-3 fatty acids, DHA and EPA, we can actually calculate the bioavailability, how much DHA and EPA are actually getting into the human subjects compared to the amount that they're actually eating. And we can compare chicken meat with eggs and also with historical control values for smoked salmon, salmon fillet and cod liver oil. Bioavailability is calculated as the change per gram consumed per day in millimoles per litre per gram. For EPA, the value was 1.03, and this compares well with previous values for eating smoked salmon, salmon fillet, and even more so for cod liver oil supplements. Likewise, for DHA, the values for chicken meat at 0.29 and for the omega-3 eggs at 0.11 were comparable or superior to the salmon products and definitely superior to the cod liver oil supplements. Now, it's all very well to look at plasma levels and bioavailability. Are we having any actual impact on the best measure of tissue levels of omega-3s and the levels of the omega-3 index, which is regarded as the best biomarker of the risks and benefits attributable to long-chain omega-3 PUVAs? And remember the world map that Heather showed you, where the majority of countries are actually have a suboptimal omega-3 index and are coloured in red rather than in green. I'm going to take you through this plot fairly slowly. These subjects that got control chicken and control eggs are on the left of the plot, and you can see that the majority of subjects who ate control products actually had a high risk omega-3 index. They had an omega-3 index which was less than 4%, 68% of them. In those that ate omega-3 eggs, there was less in this high-risk group. In those who got omega-3 chicken, there was even less, and there was the least in those that got omega-3 chicken and omega-3 eggs, down from 68% to 34%, a halving of those in the high-risk group. And these subjects have redistributed to have either an intermediate risk of cardiovascular events or a very low omega-3 index, an omega-3 index of greater than 8%. So the conclusions from our nutritional clinical trial, particularly the double-blind clinical trial, is that regular consumption of omega-3 PUVA-enriched chicken meat and eggs results in increased levels of the protective omega-3 PUVAs, a halving of subjects with a high-risk omega-3 index. Omega-3 PUVA-enriched chicken meat and eggs offers consumers an attractive additional or alternative source of long-chain omega-3 PUVAs. Improved omega-3 PUVA levels in humans is likely to lead to substantial human health benefits, protection from heart attacks, strokes, dementia, depression, cancer, and diabetes mellitus. Now, this is not a new concept that a food product could provide greater benefits than popping pills. The conclusion of a recently published study concerning fruit and vegetable intake was that eating loads of fruit and vegetables, up to 10 portions a day, may give us longer lives. Such eating habits could prevent 7.8 million premature deaths per year. By contrast, vitamin pills have not been shown to save any lives. The benefits of fruit and vegetables may be due to the complex network of nutrients that they hold. I think if we're going to recolor the omega-3 index world map green, we're going to need multiple contributing sources. Our omega-3 chicken and omega-3 enriched eggs can probably move the majority of subjects or the majority of countries from being coloured red to a more orange and brown intermediate omega-3 index. But if we're going to move the whole way over to most, if not all countries having an average omega-3 index greater than 8%, we're going to need contributions from wild oily fish, from farmed oily fish, from naturally enriched meats, naturally enriched eggs, biofortified food coatings, biofortified dairy foods and supplements. And you can see here, I've looked at what are the pluses and minuses of each of these sources. We do have to consider how sustainable are the oily fish, either whether they're wild or whether they're farmed. And we certainly have to consider the freedom from toxins, the stability and the bioavailability of supplements. And it may be that our biofortified products will behave more like supplements and have issues with stability, freedom from oxidation, and bioavailability. But that'll have to be tested. I think we will need all sources to contribute if we're going to get the world map coloured green. This will require many stakeholders working collaboratively. So we'll need to use education. We need to let people know the risks and benefits associated with low and high omega-3 levels. We're going to need to support the development of multiple sources with proven stability and bioavailability. We're going to have to promote foods and offer lots of foods that are naturally enriched with omega-3 PUVAs. And lastly, labelling. We're going to need to ensure that there's clarity of nutrition labelling on all food products, enabling consumers to make informed choices. Thank you for your attention, and both Heather and I will be delighted to answer any questions that you might have.